Hello all, this is Abhinash. In the last two videos, we have built the infrastructure of DHCP, where we have seen how DHCP DORA process work over broadcast, and we have also observed the distribution of IP address across the router. We are continuing the building of infrastructure. In this video, we are going to build the infrastructure of DNS. Let us start with the DNS server. Here we have built this DNS server, and role is already installed. And you can see here in the server manager. So let us open the DNS console. Let us create one new zone. So we are going to create a zone for our company, winsoffice.com. See here, winsoffice.com.dns. This is the name of the database where the DNS keeps all its records. We will see here. Next, allow both non-secure and secure dynamic updates for the time being. We will see what is this and how to use that. So we have created winsoffice.com, the same zone and forward lookup zone and domain. We can create this way as well. We can create as com zone, com, and then next we can create a domain. Both works the same way, right? So we will work with this winsoffice.com. Let us create one host record, the first DNS server host record, new host. 10. Create associate pointer record. I'm not going to do this at this moment. Okay, and then we are done. Let us check if that works. We have just created. Let's see our client. You see here the busy info details and IP config/all. Not this one. Yes. Oh, you see here 12, and the DNS is getting 10, as we have already given in the DHCP. DNS server is 10, right? We should start the netmon tool, our favorite one. Netmon, close, and then Ethernet 0. Okay, then new capture tab. And now let us apply the rule. This is the rule. You can see here. DNS foreground is white, background is black. And we should arrange the columns in this way. Frame number, then protocol, and then source. You see here. So let's do one thing. We have created the record in the DNS as you see here, and we will do a resolution from the client end. Ping server 1.winsoffice.com, and the most important information for us here is the this information, server 1.winsoffice.com. It is resolved by the DNS server and it got the IP address of 10. So let's see on the monitoring things if it has monitored something. We did not start that monitoring, so let's start the monitoring one more time, and one more time server 1.winsoffice.com. So we see here in DNS, ICMP, ARP, but we don't see the DNS here. Why? Because it has already resolved earlier and it is saved in its cache. So how to view the cache on the client computer? IP config / display DNS. If you see here, this is the cache information, but this is the cache information that the client computer has. Let us clear it. Flash DNS. And then let's then ping. It should start monitoring. Okay, it is from 12. What is this? Self.avin, this one. Server1.avinsoffice.com. You see here the query, and the queue record is the query record, and you see here what is the query actually, server1.avinsoffice.com, and it is using port 53672. That is source port. It is a dynamic port. To the destination port is 53, and the protocol is UDP. You see here. So DNS works on UDP on port 53. So let's see the frame number 25, which is a response from the DNS server, and the source port is 53, and destination is the same as it was from the client side as the source port. So you see here it's a success. Success means DNS has the information of this particular query, and it has responded to the client computer. See here, there is one more record. This is called a record. See here, resource name is server1.avinsoffice.com, and what is the IP address? So client computer now has the IP address of server1.avinsoffice.com. What if we ping FQDN name which is not available with the DNS? Let's see. Let's ping something else, and then ping. Okay, let's ping something else. Something else.com. Maybe like www.somethingelse.com. Let's see. Ping request could not find the host. How quick the response was. Let's see. It is also getting monitored. Where it is, scroll down here. What is here? Yes, it is office, about office.com. Here, something else. See here. The query is somethingelse.com. And what is the response from the server side? See here, name error. You can also see here name error. So this particular FQDN doesn't exist with the DNS. So it has responded with the error. And when you see, there is no a record. In the previous response, we had seen a response record with a record. But in this record, when it doesn't find any requested FQDN, it responds with server error, name error. Okay, so let us create some more domain, maybe new zone, mydomain.com, not like this, .com. Next, and then finish. Let's create to record something like www, yeah, and then 10.0.0.100, and let's see what happens if we request ping www.mydomain.com. See here, it received a reply that it has one IP address. So we can see here the response in the net1. Come down, something different. Mydomain.com. See here, mydomain.com, and what is the reply from this DNS server? Its IP address. So it works fine. Let us work with the database, and let's see something different, which is very interesting as well. You will surprise. You know where is the database? If you click on here, properties, you will see here as the name of the file .dns, and this is kept in Windows System 32. Let's open it. You see here avinsoffice.com.dns. So let us open it with Notepad. Let's see what is written here. What is written here? The information. Let me open the properties of this domain. Start of authority. See all the information what you see here is written. So this is the database, right? Now my question is, uh, what if I write IP address in the database itself? Let's see, server 10 a record and something like 172.16.0.20 and save it. Should it display here? If I refresh here, it is not displaying. But why it is not displaying? The all this information which we have created is in the memory only, in RAM. So reload it, reload and see server 10. So if I create, if I copy 21, 22, 23 and save it, reload it, refresh it. Yeah, it works. Let us have a look on NSLookup. So NSLookup is one of the command of DNS. So I'll just write here NSLookup. You see here, it is timed out 2 times. So somewhere something is failed. Client has requested NSLookup. RD record. So it is looking for pointer record this time. So NSLookup by default looks for pointer record. Have we created the pointer record? No. So what we have to do here? We should create a pointer record of which this IP address. See the reply here from the DNS server. Server failure. Pointer domain pointer, it's failure because we have not created the pointer record. Let's create the pointer record. Reverse lookup zone, right click, new zone, and then we should create a new zone here. Next, 192.168.0, right? It will automatically take this one 0.19168.192 in add ADR ARPA. The same query was raised by the NSLookup. You see here 0.168.192.in at 10 is the IP. Whenever we create reverse lookup zone, we create with the network ID. See here the network ID. Next, and then finish. So let's right click here, properties, and update pointer record. It should update it here. This time it updated. So now if we query the NSLookup one more time, will it be successful? NSLookup. See, this time default server and it is successful. So here client 1 has requested RD success. Client 1 has requested this was server 1, and then server has responded with RD success. Pointer record has requested. So we come to know that NSLookup works on pointer record. We can also see the database file of the reverse lookup zone and go to the same DNS folder. You will see here a file is created. Double click on here and open with notepad. You will see it's kind of pointer record.